Rational equations. These are equations that have x in the denominator. An example is written there. We've got x squared plus x minus 2, which is a quadratic in the numerator, and in the denominator we've got x minus 1. Okay, and then it's an equation because we have an equal sign and it's equal to 0. So before we go through the steps of solving that equation, I want to talk a little bit about zeros in relation to fraction. Let's start off if we've got a 0 in the numerator of a fraction. If we have 0 in the numerator and any non-zero expression or number in the denominator, the result is 0. All right, so 0 over 6 is equal to 0. 0 over 3x equal to 0. 0 over x minus 1 equals 0. I think you get the idea. Anytime we've got 0 in the numerator over something that is non-zero, then that whole thing is equal to 0. Okay, now what if we have 0 in the denominator? It's like we flip that over, we have 6 over 0. Okay, well, we cannot divide by 0 because there is nothing that we can multiply 0 by to get back to that 6. So when we have 0 in the denominator, we say that it is undefined. So 0 in a denominator is undefined, meaning there's just no way to define it. And it is something we want to avoid. Okay, so let's do an example of how we can ensure that we avoid having 0 in the denominator. Let's say we have 6 over x. All right, well, if we don't want to have 0 in the denominator of that expression, we would say that x cannot equal 0. All right, let's look at another one, and let's say we've got 5 over x minus 1. All right, well, if we want to avoid having 0 in the denominator, then we want x minus 1 to not be equal to 0. And then if we solve that for x, add a 1 to both sides, just like if we have an equation with an equal sign. All right, we're going to get x not equal to 1. So if we have this expression, 5 over x minus 1, we can ensure that it won't equal 0 as long as we choose values of x that are not equal to 1. Now let's look at this example that we started off with. First thing we want to do is get rid of that denominator, x minus 1. So to do that, we are going to multiply both sides by x minus 1, that denominator. Okay, so as long as we multiply both sides by the same thing, we keep both sides of the equal sign the same, all right, or we keep them equal. Okay, so we choose multiplying by x minus 1 because that is going to allow us to cancel that factor of x minus 1 from the numerator and the denominator of the left side. Okay, so we're going to be left with, on the left, we're going to be left with just x squared plus x minus 2. And on the right side, we have 0 times x minus 1. Anything times 0 is equal to 0. We have gotten rid of the denominator, and we just have a quadratic equation now. We can use our methods of solving quadratics to come up with the values of x that solve this equation. So we will try to factor. We have leading coefficient of 1, so that means that we're going to have two linear factors. They both start off with x. And we want two numbers that multiply to a negative 2 and add to a positive 1. So that's going to be plus 2 minus 1. Okay, we set both factors equal to 0 and solve for x. And we end up with x equal to negative 2 and x equal to a 1. All right, now these are answers and they are correct answers, but we want to check them back in the original equation to make sure that they are valid solutions. So we can think about taking that -2. If we plug that back into the equation, we are not going to get x in the denominator. So x equal to -2 is a valid solution. Okay, but if we plug in a positive 1, all right, if we plug that into that denominator of x minus 1, right, 1 minus 1, that would be a 0. So even though we got this answer, it is not a solution and we have to exclude it because we cannot allow x to be equal to 1. Okay, here's another rational equation. This time it's rational because we have that 3 over x as one of the terms. Now, one way we can start off is to just immediately write down the value that x can't equal. So what value is it that we have to avoid? Well, we don't want the denominator to be equal to 0. It's just x in the denominator, so we're going to say that x can't be equal to 0. All right, now let's go about solving this. So here's a case where, again, we're going to want to clear the denominator. So that means we multiply both sides by the denominator. So we are going to multiply this entire side, the right side, by the denominator of x. And that means we also do that to the left side. All right, so let's rewrite what we've got now. So x times 2x is 2x squared. Now we distribute this x to both of those terms. All right, so 7 times x, we get 7x. And when we multiply -3 over x times x, those x's are going to cancel out. Okay, so those are going to cancel out. So it gets distributed here to the 7x, but they cancel out of the 3 over x, so that just leaves a -3. Okay, known more denominators. Now we have a quadratic. So we know the first step of solving a quadratic is to get all the terms on one side if we're going to try to factor. So if we add 3 to both sides, we get 2x squared minus 7x. Actually, we need to add 3 and subtract 7x. So 2x squared minus 7x plus 3 equals 0. This is one that we are going to either try to factor by grouping, or we could use quadratic formula. Either one I think is going to work in this case. We could actually use completing the square. All right, you might want to pause the video right now and give it a try yourself for some practice. I'm going to go ahead and use quadratic formula. So let's use x equals, and then we want -b, so that's 7, plus or minus the square root of -7 squared, which is 49, minus 4 times a times c. So 4 times 2 is 8 times 3 is 24. So we're going to subtract a 24 all over 2 times a, which is 4. All right, so working through the arithmetic here, we're going to have this 7 plus or minus the square root of 25 all over 4. So you get x equals, all right, square root of 25 simplifies to 5. All right, so we're going to have x equal 7 plus 5 over 4, so 12 over 4 equal to 3. And we will have x equal to 7 minus 5, which is 2 over 4, which will simplify to 1/2. All right, so we get two solutions. Here, I'll just circle them. 3 and 1/2, and we just double check, make sure that they're going to work in the original equation. All right, well, we already wrote down that x can't equal 0. So both of these solutions are valid because they are not 0.